Like all stars, Insect will eventually run out of fuel in its core, causing significant transformations. The star will begin to expand, reaching the orbits of Mercury and Venus, and may even come dangerously close to Earth. The reality that Insect is dying is a tough truth for astronomers to accept, but there's nothing anyone can do to stop it. The enormous star is on the verge of a supernova, and experts predict that it could happen any time, whether tomorrow, next month, or in a few months. The precise date is unknown, but one thing is certain. Insect is reaching the end of its life, and this impending explosion will forever alter our understanding of the universe. Why is Insect supernova so significant? And what could happen if the star were to detonate today, as scientists expect? Join us as we explore these critical questions in this exciting video. NASA's chief has issued a warning to the world about the imminent explosion of Insect, predicting that its demise could lead to drastic changes in our planet and our existence. Like a terminally ill patient nearing the end, Insect is moving closer to its final moments, and its death is inevitable. For decades, astronomers have been closely studying this star, eagerly observing its behavior as it nears its explosive end. What many had feared is now a certainty. Insect is heading toward annihilation, and its death is likely sooner than expected. Insect is one of the most fascinating stars in the Milky Way and has captivated astronomers for years. This red supergiant star, whose brightness fluctuates between 0.3 and 1.6 times that of other stars, is notable for its unique characteristics. In fact, it holds the title of being the star with the widest brightness variation. The famed astronomer TMY, an Alexandrian mathematician and geographer, dedicated years to studying Insect, providing early descriptions of this red giant. Interestingly, indigenous groups in South Australia have long passed down oral stories of Insect variable brightness, a phenomenon that has been observed for over 1,000 years. In recent years, advances in astronomy have given scientists a clearer picture of Insect and its properties. Located in the constellation Orion, Insect is one of the largest stars known, with a diameter ranging from 100 million to 1 billion kilometers, making it one of the most colossal objects in our galaxy. If we were to place Insect next to our Sun, it would be 100 to 1,000 times larger. This massive star is in the final stages of its life, having exhausted the fuel needed for nuclear fusion in its core. Without the heat and pressure needed to counterbalance its enormous size, Insect will eventually collapse. Red supergiants like Insect are among the most massive stars in the universe. Unlike smaller stars like our Sun, which becomes a red giant when it runs out of fuel, a red supergiant forms when a star with more than 10 times the Sun's mass reaches the end of its life. As the star runs out of fuel, it no longer produces the necessary heat and pressure to maintain its weight, causing it to expand and eventually explode. Insect-Jur's immense size is not only reflected in its brightness, but also in its position among the brightest stars in the night sky. It ranks as the 10th brightest star and the second brightest in its constellation, trailing only behind Rigel. However, if we look at infrared wavelengths, no other star would compete with Insect-Jur for the title of the brightest star in the sky. In comparison, the Sun appears faint when placed beside the overwhelming size of Insect-Jur. The star's diameter is about 1,000 times larger than that of the Sun, meaning that if it were at the center of our solar system, it would extend past the asteroid belt, engulfing the orbits of Mercury, Venus, Earth, and Mars. Estimates of Insect-Jur's mass place it between 10 and 20 times the mass of the Sun. Despite its massive size, this star is relatively young, only around 10 million years old by astronomical standards, which is quite young compared to the Sun's age of approximately 5 billion years. However, while Insect-Jur may be younger, its sheer size far surpasses most other stars in the universe. Because of its pulsating nature, it has been difficult for astronomers to accurately measure its size, and the star's fluctuating size makes it even more challenging to pin down its exact diameter. Additionally, its outer layers are constantly obscured, complicating efforts to understand the true extent of the star's reach. The inevitable collapse of Insect-Jur marks the end of an era in the universe. Its death, while catastrophic, is also a natural part of the life cycle of massive stars. When it eventually explodes, The consequences will reverberate far beyond the immediate vicinity, fundamentally altering our understanding of the cosmos. The varying intensity of emanations decreases as one moves further from the core, and the star is surrounded by an envelope of material expelled from it, making it difficult to precisely define the photosphere. Additionally, a star's apparent size depends on the frequency used to observe it. The Earth's atmosphere also plays a role in limiting the resolution achievable by ground-based telescopes, as atmospheric turbulence reduces angular resolution. These factors make it challenging to accurately determine the size of the star. However, scientists have still made estimates of its diameter. Another puzzle presented by this massive star is its complex and extensive environment. While astronomers know that mass in galaxies is recycled through the formation and destruction of stars, they have not yet figured out how mass is lost during these processes. Despite this mystery, recent findings about this star, often referred to as Scarab-Jur, are far more astonishing. While it is well known that this star has a massive size, many are unaware of how quickly it has grown over the years. The star's increasing mass and development over millions of years can be plotted on a graph, showing its rapid expansion. Now, here's a shocking revelation. Scarab-Jur is nearing the end of its life. This red giant star is expected to reach the end of its development soon and could explode into a supernova at any time. Researchers have determined that Scarab-Jur is on track for a supernova, a powerful and luminous explosion that occurs in the final stages of a massive star's life, or when a white dwarf undergoes runaway nuclear fusion. If Scarab-Jur were to explode today, the optical brightness of the supernova would rival that of an entire galaxy. This dazzling display would be visible for weeks or months, offering a breathtaking and awe-inspiring sight for anyone witnessing the event. Interestingly, Scarab-Jur is visible to the naked eye at night, but it becomes nearly invisible in May and August when it is near the sun. Scarab-Jur is also one of the 3 stars that form the winter triangle asterism and marks the center of the winter hexagon. From the beginning of January each year, the star rises in the east after sunset, remaining visible from mid-September to mid-March across most populated regions of Earth, except Antarctica, and areas south of 8 degrees latitude. So, on a typical night, once darkness falls, Scarab-Jur can be spotted among the array of stars decorating the night sky. If Scarab-Jur were to explode today, the entire world would witness the aftermath. The supernova would be as bright as the half-moon for over 3 months, changing the appearance of the night sky. Given that Scarab-Jur is only 642 light-years away, its explosion would have a noticeable impact on Earth. This proximity means the cosmic blast's effects would be felt here, leaving no doubt that something significant had occurred in the cosmos. The star's luminosity, however, is not constant, which may seem surprising to some. But Scarab-Jur is a pulsating semi-regular variable star, which means its brightness fluctuates due to changes in its temperature and size. When astronomers first discovered this variation, they were taken aback, as the star's brightness would suddenly rise and fall over a period of days or months. This unpredictability made it difficult for astronomers to study the star, causing significant challenges in understanding its properties. It took years for scientists to accurately measure its brightness due to these fluctuations.